Have you ever found yourself, that maybe looking up at the stars or just thinking about the incredible dance of particles happening all the time and really wondered, what if the universe isn't just a bunch of stuff and forces? What if it's something, well, deeper, more interconnected, maybe even driven by some hidden principle of resonance? Like, what if reality is less like a machine and more like a vast, evolving symphony?
That's a question that's, well, it's been echoing through the ages, hasn't it? From ancient philosophers to modern physicists, we've learned so much, Newton, Einstein, quantum mechanics, incredible stuff.
Yeah.
But there are still these gaps, these persistent questions. How does gravity fit with everything else? Where does mass really come from? Why does reality seem to, well, solidify when we look at it? These aren't trivial.
Exactly. And that's precisely the territory we're exploring today. We're doing a deep dive into a really revolutionary, pretty cutting-edge paper from 2025 by Philip Randolph Lillian. It's called Noetherian Finsler Numbers, a coherence algebra of dynamic symmetry, phase, and recursive geometry. And Lillian isn't just tweaking things here. He's proposing a fundamental shift, really, in how we see physics, from the tiniest quantum level up to the cosmos. He introduces something totally new, Noetherian Finsler Numbers, or NFNs for short.
Right. And our mission today, yours and mine, is to sort of guide you through this. It's dense stuff, no doubt, but incredibly fascinating. We want to pull out the core ideas, the surprising bits, the aha moments. Think of this as your shortcut to getting your head around a theory that could genuinely reshape how we think about everything. We're going to unpack how these NFNs try to weave together ideas from, well, Noetherian symmetry, that's about conservation laws, energy, momentum, with Finsler geometry, which is a more dynamic way to look at space, and also coherence field dynamics, all into one sort of elegant framework.
And here's something really captivating right from the start, something that challenges, what you even think a number is. NFNs aren't just static values. They're described as operator-valued dynamic entities. Just let that sink in for a second. It's not just a number describing something. It's a number that acts on fields. It shapes them, transforms them, maybe even creates them. Imagine, not just a label on a map, but a tiny crew on the map, constantly rebuilding the terrain based on what's around it. They're not just representing reality. They're actively doing it.
That's the core shift. It means a particle isn't just at a location. It's this dynamic node shaping the location through its NFN. Physics becomes active generation, not just passive measurement. And this leads to maybe the biggest leap. The idea that coherence, this harmony, this integrity, isn't just a side effect. It's proposed as the fundamental, the deepest invariant. Deeper than energy, deeper than force. Lillian suggests coherence is the cosmic glue. So, yeah, prepare for a bit of a mind bender.
Okay, deep breath. Let's start at the beginning then. What exactly are these Noetherian Finsler numbers? Why are they such a, well, frankly, radical departure from the numbers we usually use in physics?
Well, the whole idea starts by moving beyond how physics traditionally describes things. For centuries, right, we've used fixed static numbers, real numbers, complex numbers, quaternions, and quantum stuff. These numbers describe a quantity. Temperature, velocity, position, they tell you what or how much. But they are fundamentally snapshots. They represent a state.
Right, like taking a picture. You get a value, a label for that instant. Descriptive.
Exactly, descriptive. But NFNs, as we said, are operator-valued dynamic entities. That's the key phrase. Instead of just describing, they act on fields. They're involved in the continuous evolution, the transformation. Think of it less like a number on a page and more like a little algorithm that just by being there does something to the space or the fields around it. It's constantly reshaping things.
That's a huge conceptual jump. Numbers with agency. Yep. Okay, so how are they structured? What are the parts of this dynamic acting number?
Lillian defines each NFN as a four-tuple. Not just four numbers, but like a four-part toolkit or instruction set. The components are labeled S, A, Phi, and Chi, and each one plays a dynamic, interconnected role in describing how coherence evolves, how it stays stable, how it changes, how it kind of remembers itself.
Okay, let's break those down. This is like the basic grammar. First up, S. What's the S part? Does it relate to symmetry, like the name suggests?
Yes, S is the symmetry operator. Now, in regular physics, symmetry is super important, leads to conservation laws, right? Like energy conservation comes from time symmetry. With NFNs, S still governs conserved quantities. But here's the twist. It specifically governs coherence stability. It doesn't just conserve energy within a field, it actively helps structure the local coherence field itself. Think of S as the part that ensures harmony and order persist, like the rhythm section in this cosmic symphony, keeping a steady beat. It's the anchor.
So S is about integrity, harmony, keeping things stable, but actively.
Okay.
What about A? Sounds like it might be disruptive.
A is the asymmetry generator, and you're spot on. This is where the dynamics, the tension comes in. If S maintains stability, A is the engine of dynamic emergence, instability, directional force. This is where new stuff literally arises. If S is persistence, A is nullity, change, the creation of form. It introduces the tension or distortion needed for evolution. It's the improvising soloist, pushing boundaries, creating unexpected variations.
Okay, S the anchor, A the engine of change, driving away from perfect symmetry to new forms. Then phi. Phase, I'm guessing?
Precisely. Phi is the phase modulator, absolutely critical. It defines coherence, interference, and resonance alignment. Think of tuning an instrument or how waves combine constructively or destructively. Phi dictates how fields align, when they resonate perfectly, when they clash. It's like the cosmic mixer, ensuring systems line up to form stable structures or misalign for dynamic interactions.
And the last one, chi.
Yeah.
This one sounds deep. Recursive memory coordinate.
Yeah, it's the recursive memory coordinate. This is really unique. It represents dimensional recursion and coherence memory. Think fractals or nested layers, like Russian dolls, where each doll kind of remembers the others. Or like DNA carrying the memory for a whole organism across scales. Chi governs this nested, self-referential quality. It allows complex, layered structures to emerge and retain information about their history. It's like a memory embedded in reality's fabric.
So putting S, A, and Sech together.
Yeah.
Well, what's the big picture? NFNs sound like way more than just labels.
Way more. They describe the evolving structure of coherence, not just static states. They aren't just representing fields, they are actively acting on them, generating, modulating, transforming coherence itself. They capture how a system keeps its identity while changing, how it resonates across scales, how it encodes its history. It's a universe constantly building and remembering itself, harmonizing itself.
That's a monumental shift. If NFNs are defined by these operators constantly acting, it forces us to rethink what's fundamental. We're so used to energy, force, gravity being the bedrock.
And that brings us straight to maybe the biggest paradigm shift in Lillian's work. The idea that coherence, not energy or force, is the most fundamental invariant. That's not just wordplay. It's reprioritizing what holds reality together.
That's bold. I mean, physics built on energy conservation. How does coherence take center stage? What does it really mean here? Is it just things being in sync?
It's deeper than just in sync.
Yeah.
Lillian defines it as a system's capacity to maintain identity through transformation, to resonate across scales, and to encode memory through recursion. Think of like a complex dance. The dancers move, change, interact, but the coherence of the dance, its pattern, its harmony persists. That underlying integrity, even amidst constant change, is what NFNs see as fundamental. It's about structured persistence, resonant connection.
So it's about the deep harmony, the integrity, the cosmic rhythm that lets things persist and evolve even while they're in flux, like the underlying melody of a song, right?
Yeah, exactly. And the NFN framework makes this operational. Each part SA explicitly contributes to or modulates this coherence. S ensures stable patterns. A introduces the curvature for new structures to emerge, handles the resonance tuning, getting things aligned, and encodes the depth, the layering, letting coherence span scales and remember itself, like a fractal pattern holds its structure at any zoom level.
Okay, this is where it gets really interesting for me. Imagine a universe where the glue isn't just energy, but this kind of cosmic harmony, this structural resonance. It sounds almost alive. And Lillian grounds it in math. Reality isn't just particles bouncing around. It's this constantly unfolding coherent symphony, not just a metaphor, but the actual operating principle.
That's a great way to capture it. It highlights that NFNs aren't just descriptive, they're generative. They don't just tell you about coherence, they create it, they modulate it.
So beyond just being these dynamic things, what do NFNs actually do? What are their roles in shaping this coherence-driven reality?
They have several crucial interlinked roles. They act as generators, operators, and ultimately unifiers. First, they function as generators of coherence eigenmodes. This means they produce specific, quantized, stable modes of resonance within a field, like preferred songs or patterns the universe naturally falls into. Just like an electron has discrete energy levels, NFNs dictate specific, stable coherence patterns, the universe's resonant frequencies.
So they're like the universe's preferred ways of organizing itself harmoniously, not just any old state.
Exactly. Second, they don't exist alone. They fit into a larger structure. Lillian calls the Coherent Symmetry Group, CSG. This is like the grand framework unifying symmetry, asymmetry phase recursion. It provides the rules, the context for how NFNs operate and interact, the complete score, if you will.
And quantum theory, you mentioned NFN QFT. Does this replace standard quantum mechanics?
That's a key point. NFNs serve as operators in a novel quantum field theory, NFN QFT. Now, traditional QFTs quantize space-time and energy fields. NFN QFT is built fundamentally on coherence. It reimagines quantum interactions and particle behavior as emerging from coherence itself, not as fundamental entities in their own right.
That's huge. Suggesting an even deeper layer to reality. Does this new approach offer solutions to existing problems, like where mass comes from?
It proposes one. Lillian suggests NFNs offer an alternative to the Higgs mechanism. Instead of mass from interacting with the Higgs field, NFNs suggest mass might arise from coherence condensation. This would be where specific coherence eigenmodes, these stable songs, sort of solidify or condense into observable structures, giving rise to the inertia we perceive as mass. Imagine a resonant harmony suddenly taking physical form.
So mass isn't about hitting some invisible field. It's about the density, the alignment, the stability of coherence itself, like a kind of cosmic crystallization. That would certainly change things for particle physics.
That's the profound idea. And importantly, NFNs aren't just abstract theory. They provide a path integral and matrix formalism. That means they offer concrete computational tools. Physicists could potentially use NFNs to simulate how structures emerge, how spacetime behaves under extreme coherence. You could model the early universe based on shifting coherence patterns, not just energy equations. It gives scientists new tools to build models and make testable predictions.
Right, making it actual science, not just philosophy.
Yeah.
And the ultimate goal, the grand unification.
The unification pathway aims to show that standard quantum fields and gauge forces, electromagnetism, nuclear forces are just projections of deeper coherence structures.
Huh?
What we see as fundamental forces and particles are, in this view, just specific manifestations, particular harmonies of the underlying NFN coherence. It's a vision for unification based on a single coherent source.
It's like we're seeing shadows, and NFNs might reveal the objects casting them. Which brings us nicely to the stage itself, the geometric substrate, these Noetherian Finsler fibers.
Exactly. To get NFNs, you need to understand the space they operate in. Our current picture, especially in general relativity, uses Riemannian geometry.
Right, where geometry depends on position. Near a massive star, space warps, distances change. But it's uniform in all directions from that point, right?
Correct. Metric depends only on location. Finsler geometry is, well, it's a more general, more nuanced picture. The metric, how you measure distance, depends not just on position, but also crucially on your direction of travel, or velocity. Imagine walking in a thick forest. How hard it is, the effective distance, depends not just where you are, but which way you're going. Uphill versus downhill, maybe. The space feels anisotropic, directionally dependent.
So space itself has a preferred direction, or at least responds differently depending on direction.
Yeah.
Why is that anisotropy so vital for NFNs?
Because it naturally encodes things essential to NFNs: coherence gradients, observer dependence, path-sensitive dynamics. It's the natural substrate because NFNs are dynamic and directional. They act on fields with flow, alignment. The geometry needs to reflect that. Finsler geometry allows space to bend or stretch, not just due to mass, but due to the flow, the density, the alignment of coherence itself. It's a geometry that's alive to the cosmic symphony.
So the stage is active, responsive. Okay, so tell us about the core geometric thing here.
Yeah.
The Noetherian Finsler fiber, Feliver X. How is a fiber different in this theory?
Right. In traditional math, fibers are often abstract vector spaces. Lillian redefines them as active resonance nodes or local coherence bundles. They aren't just passive spaces where fields exist. They're dynamic systems, like tiny cosmic resonators. They actively shape, modulate, and generate coherence at every single point, like the fundamental pixels of reality. But each pixel is a dynamic, self-organizing system.
And like the NFNs, these fibers also have a four-tuple structure. Walk us through those components: sigma x, cx, nx, and omega x.
Absolutely. At each point x, the fiber fx is the tuple. X, cx, and xx. First 6 is the symmetry layer. This is the local symmetry group, or algebra at that point. Could be familiar ones like U1, SU2, SU3 from the standard model, or others from the overarching coherence symmetry group. This layer gives rise to the conserved coherence quantities. It's the local rulebook, encoding the persistent patterns the symmetries present right there.
Sets the local rules for harmony. Got it. What about CITX, the coherence metric field?
CX is the coherence metric field. This is the Finsler metric we talked about, depends on position and direction. It shows how local geometry bends or stretches based on coherence, density, flow, alignment. It's directional. If coherence flows strongly one way, geometry might warp differently in that direction. It's the local texture or topography of coherence shaped by the coherence flowing through it.
A dynamic, almost fluid picture of space. Okay.
Yeah.
And X.
NX is the Noetherian charge spectrum. These are the conserved quantities rising directly from the symmetry layer, SPIPs, like quantum numbers, but Lillian says they're richer in ontological function. They don't just label states, they represent local stability, potential emergence channels, phase boundaries. They're the eigenvalues of the symmetry modes. If X is the rulebook, Xers are the specific conserved results, like quantum tags describing the local coherence properties.
And finally, omega X. Sounds complex curvature coherence operator.
X is the curvature coherence operator. It's a generalized curvature torsion operator. It captures how the space is dynamically twisting or curving because of complex field configurations, phase interference, recursive layering. It defines how local geometry is sculpted by the coherence structure itself. If coherence fields interfere or layer in complex ways, X accounts for that specific geometric distortion. It's the dynamic sculptor of reality at that point.
So the fiber, X, isn't just a snapshot. It's a dynamic, active generator of emergence, a little engine of reality at every point.
Exactly. Lillian calls X a coherence generating system, the local engine shaping and modulating coherence into observable phenomena. Reality emerges dynamically from this modulation along these fibers, guided by S, A, 8, and Kirch. It's a universe singing itself into being, fiber by fiber.
So the fiber is the engine. But how do we actually get the NFNs, the numbers themselves, out of this engine? What's the mechanism?
That's where the coherence eigenvalue problem comes in. To extract the meaningful quantized values, the NFNs, from these fibers, Lillian defines a composite operator, dx, which acts on a field, psi, within that fiber.
And what does this dx operator involve? What pieces does it combine?
dx is quite elegantly constructed. It includes a directional derivative sensitive to the Finsler metric, so it knows about coherence, flow, and warping. It has a resonance curvature action operator, rex, capturing how spatial twists affect coherence. And finally, a symmetry projection operator, ensuring only coherent symmetrical patterns are picked out, so it accounts for direction, curvature, and symmetry all at once.
Okay, so you apply this complex dix operator to a field and solve an eigenvalue equation, like finding energy levels in quantum mechanics.
Precisely like that. The equation is dx equal 1. Solving this gives you a set of quantized values, aui, lambda I. These are the Noetherian Finsler numbers. They aren't arbitrary. They are field-defined, location-specific coherence eigenvalues. They're the natural, inherent resonance frequencies of the coherence field at that point, given its unique local conditions.
And what do these NFNs, these lambdas, actually represent? What's this spectral fingerprint telling us?
They characterize the total resonance condition of the fiber at that point. They define a coherent spectral fingerprint of physical emergence. Essentially, they capture the precise degree of alignment, the curvature entanglement, phase sensitivity, and scale embedding. For example, if Chix relates to U1 symmetry, the NFN might represent an electromagnetic coherence resonance, like a light frequency. If the space is very anisotropic, the NFN becomes path-dependent, reflecting that Finsler curvature. They tell you how much coherence is manifesting as form right there.
What's fascinating here is these aren't just numbers describing something static. They are field-defined, location-specific coherence eigenvalues that measure the degree of alignment, curvature, entanglement, and emergent symmetry breakdown at the fiber. They measure how coherence becomes form, dynamically, point by point, like the universe taking its own pulse.
That's it, exactly. It drives home this idea of reality continuously emerging, modulating, defining itself, not built from static blocks. It's a universe in perpetual generative motion.
Which immediately begs the question, what about the observer? If reality is modulating based on coherence, where do we fit in? Are we just watching the show?
Not even slightly. This is one of the most, well, philosophically rich parts of the NFN framework. It fundamentally challenges the idea of a passive, external observer. In NFN theory, the observer is an active agent of transformation, encoding a particular orientation, a coherence profile within the whole landscape. You aren't just looking at the universe, you are actively participating in structuring it through your observation.
So observing isn't just seeing, it's influencing the coherence, the structure itself. Well, that's radical even compared to quantum mechanics interpretations. How does that work mathematically?
Lillian introduces observer morphisms, written as OFEP-UX. This isn't just changing coordinates, it's a coherence morphism, a transformation that maps the internal structure of the fiber into another frame. It involves a mathematically precise reconfiguring of the fiber's core components, symmetry, metric, resonance modes based on the observer's own coherence profile and interaction.
An observer shift literally transforms the fiber's insides. That sounds incredibly complex. Can you give us a feel for how the different parts, CX and X, might change?
Yes. The paper lays out specific rules. Think of looking at a scene through different lenses, not just color filters, but lenses that reshape the scene based on how you hold them, maybe even your focus or attention. So for symmetry layer, it might reconfigure or even reduce. Like if the observer has lower coherence, a complex SU2 symmetry might look like a simpler U1. The lens simplifies the pattern seen. For Seamstone's coherence metric, it gets distorted by a Jacobian matrix based on the observer's motion and state. The perceived coherence topography stretches or compresses depending on how the observer moves through it. For Seamster, Noetherian charges, they undergo a unitary transformation. The conserved quantities get renormalized or redistributed from the observer's frame, like a tinted lens making some colors pop more than others. And for Seamster curvature coherence operator, it transforms and gets a correction term accounting for frame-induced torsion or coherence drag. The lens doesn't just distort, it adds twists to the perceived reality, sculpting the geometry.
That's intricate.
Yeah.
And kind of mind-bending. It means what we perceive as geometry and fundamental quantities is shaped by our observational frame, maybe even our own internal coherence. It's like the universe is a symphony and our listening device co-creates the sound.
It is like that. But crucially, certain coherence invariants are preserved. Ratios of eigenvalues might stay constant, or the trace of another spectrum, TRNX. These are coherence frame covariant quantities. They're like Lorentz invariance and relativity, but related to coherence, phase, and topology. So even with all this dynamic modulation, there's an underlying structure, a core musical relationship that holds true regardless of perception.
So the underlying relationships remain, even if my lens distorts the view. And this idea of the observer as a coherence modulator, it suggests our own state matters.
Yeah. Yes, the theory suggests observers with higher coherence, maybe through internal phase locking or better alignment with the universe's structure, might resolve deeper layers of reality, see more detail, finer distinctions. Conversely, an observer experiencing decoherence, internal noise, would perceive compressed symmetries, distorted metrics, resonance laws, like looking through a smudged lens.
Which leads to that profound statement.
Yeah.
Observation is not collapse. It is a coherence morphism. It's not forcing a wave into a particle mysteriously. It's an active, structured interaction reconfiguring the underlying coherence. That's a huge departure.
It definitely is. And building on that, Lillian introduces an even deeper layer, the metafiber, FX. This goes beyond local properties to reveal a deeper ontological structure, the foundation for all this.
So if the regular fiber, FX, is like a dynamic pixel, the metafiber FX is like the atom of coherence for the whole universe, the source code.
That's a perfect analogy. Lillian calls it the minimal ontological unit of structured emergence, the field-theoretic equivalent of an atom not of matter, but of coherence. It's the ultimate blueprint from which NFNs and their actions originate.
And this metafiber also has a four-tuple structure, but different components, DX, AX, TX, RX. How do these relate to the local fiber and form this ontological atom?
These layers capture the generative aspects. GX is the geometric layer, the fundamental Finslerian metric, GX. The deep anisotropic substrate, the cosmic clay responding to coherence flow. Ax is the algebraic layer, the local symmetry algebra, Lie. The quantization engines generating conserved quantities and governing transformations. The blueprint for dynamics. TX is the topological layer, encodes the recursive fractal topology, nested coherence shells, boundaries, self-similarity, memory across scales, the universe's interconnected tapestry. RX is the resonance layer, the spectrum of coherence eigenvalues, the NFNs themselves emerging from the universal operator DX, quantifies resonance, emergence, stability, the actual music the metafiber plays.
So these aren't separate layers, but interpenetrating strata of a single coherence engine, a truly holistic picture.
Exactly. Unified. GX is geometry, AGA is algebra, TX topology, RX the spectral output. Together, they're the indivisible generative unit. The metafiber provides the space for NFN operators, the algebraic rules, the topological scaffold, and the spectral interface for emergence.
It sounds like the metafiber is the ultimate source, the universe literally getting its being from this continuous unfolding act of generation within the
The
metafiber.
vision, a complete geometrico-algebraic ontology where coherence becomes structured, physical, meaningful. It's the deepest root of existence in this framework.
Okay, let's dig into the mechanics then. If NFNs are these active operators, how do they actually work together? What's the math, the algebra that governs their interactions?
Right, and it's not classical algebra. The NFN operator algebra is inherently non-commutative, phase-sensitive, recursively structured. It's a language designed to model how structured emergence propagates, interferes, composes, evolves. The operations model real physical processes.
Okay, so if we take two NFNs, N1 and N2, how do we add them?
Addition uses a circle plus symbol called compositional overlay. It's component-wise. S1 and S2 combine linearly like forces. Phase components add modularly like angles. Recursive coordinates use complex operations like fractal convolution. Physically, N1 and N2 creates a superposed coherence structure, richer, multi-phase, multi-depth, like layering two musical scores into a more complex one.
Makes sense for addition, a richer blend? What about multiplication? That's often where things get tricky.
Multiplication uses a circle time symbol called operator composition. And yeah, this is key. It's generally non-commutative. N1 or N2 is not the same as N2, N1. Order matters. Components combine via specific rules, operator composition, fractal convolution for touch, phase multiplication for phi. This represents embedding one coherence operator structure into another's. Often produces new emergent behaviors, like adding ingredients in a recipe order changes the outcome.
Order matters. Non-commutative, like quantum mechanics.
Right.
Sounds very dynamic. And how does an NFN actually act on a coherence field, a PSI?
An NFN, N, acts on a field, X, X, like this. N, S plus A, X. Let's break that down. The phase term, IC, modulates amplitude and interference. The recursive term applies the field function over layered scales, integrating memory. Then the combined S plus A operators act, preserving symmetries, S, and inducing emergence, A. It's a full transformation of the coherence field.
Feels like a language for actively shaping reality. And then there's the coherence bracket, N1, N2C. What's that?
The coherence bracket is the commutator. N1, N2, 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 N1. It's crucial. It captures algebraic curvature between operators. Physically, it defines interference conditions for resonance clash and describes the deformation of coherence structure when emergence flows overlap.
Okay, let's unpack that. This isn't just math symbols. These operations, like the bracket, model real physics. So if two coherence patterns interact, the bracket describes their interference, maybe even how their interaction creates new curvature in the coherence field itself. A dynamic dance where even disagreement creates something new.
Exactly. NFNs are to coherence what operators are to quantum states. They generate transformations. Their algebra is the process of emergence, evolution, interaction.
So how do we actually use these NFNs computationally? Is there a more concrete way to represent them? What does a physicist work with?
Yes, Lilium provides matrix representations, which is huge for making them computable and visual. The standard form is a 2x2 coherence block, N, SA, S, 2S.
A matrix where each entry... Clever. How do we read that structure?
It's quite insightful. The upper row, S and A, handles invariant structure and emergent flow. Symmetry S and asymmetry A, stability and generation. The lower row, SN, governs emergent flow via phase and recursion. Phase for resonance, recursion for layering. It's a compact way to handle complex dynamics using familiar matrix rules, just extended for operators.
And how does this matrix act on a field? What happens when N operates on S?
A coherence field, A can be a column vector. A equals agem with geometric and recursive parts. Then N equals agem plus aric plus agem plus agem. This allows complex transformations. Resonance coupling, phase shifts, recursion layering. It's how the NFN actively sculpts the field, changing its form and behavior.
Fascinating.
Yeah.
Makes it more tangible, calculable. And this leads to a fundamental field equation like Schrodinger's.
Yes, the generalized field equation is Ne equals A. Here is the coherence eigenvalue, the NFN. It parallels quantum mechanics, age H equals, but crucially, it's about structural emergence replacing static observable measurement. The solutions A are eigenfields of coherence, stable, resonant configurations. They manifest observable structure only when the field and NFN align resonantly, like a clear note from a tuned instrument.
So we're finding states of coherent emergence, stable ways reality can manifest, not just energy states. Really emphasizes the dynamic generation. Which brings us to the huge step, quantization. How do we get from these field-shaping operators to discrete particles?
Right. This is where it becomes fundamental physics, explaining the lumpiness of the universe. Lillian proposes a quantization procedure that turns NFNs from operators into quantum-like excitatory modes that structure field resonances. This explains particles as emergent patterns, not fundamental points.
So quantizing an NFN, what does that involve? How's it different from normal quantization?
It means mapping the classical components, S-A-H, to operators, acting on a coherence Hilbert space. These operators obey non-trivial commutation relations like TUS. The new thing is AC, the coherence quantum. Analogous to Planck's constant Auger energy, AC modulates structural quantization. It's the smallest possible unit of coherence structure or pattern.
So AC is the fundamental pixel of coherent patterns, a profound constant. And when a quantized NFN acts, it creates coherence excitations. What are those?
Exactly. When a quantized NFN acts on the vacuum field, 0A, it creates a coherence excitation, A. This NA acts like a quantum particle, but it is a localized emergent structure defined by the NFN's SA Fesh configuration. It's not a tiny billiard ball. It's a specific, localized vibration, a stable pattern, a particular song of coherence in the field.
So they're structured phase topologies, not particles in the old sense,
Yeah.
like knots or ripples in the coherence fabric. Can they be bosonic or fermionic, like force carriers in matter?
Yes. If generated by symmetric NFNs, A0, they behave like bosons, photons, gluons. If they involve antisymmetric symmetry operators, they act like fermions, electrons, quarks. It's an elegant way to generate both force carriers and matter particles from the same underlying coherence framework, just as different types of coherent excitation.
And like standard quantum mechanics has ladder operators, there are NFN ladder operators too.
Correct. Creation and annihilation operators raise or lower the excitation level of an NFN mode. This defines a quantum ladder of coherence configurations. Each rung is a specific structured coherence domain, a new harmonic configuration, or a deeper recursion layer in, like climbing rungs of reality, revealing more complex structures.
This raises a huge question. If these NFN excitations replace particles and they're just structured coherence, how does that change our search for new particles? And what about mass? Does it still exist?
It does, but profoundly reimagined. In the quantized coherence picture, the eigenvalues, the NFNs, now correspond to quantized coherence masses. The equation NE implies a coherence mass, mc, proportional to Lu times in. mc encodes structural inertia and phase binding energy. It replaces traditional particle mass. Mass isn't intrinsic to a point particle. It arises from these coherence eigenvalues, from the stability and complexity of the NFN's coherent structure.
So mass isn't inherent. It's a measure of coherent state, stability, interaction. My desk isn't heavy because its particles have mass, but because of the coherence configurations giving it structural inertia. That's revolutionary. It shifts the question from what gives mass to what makes coherence patterns stable enough to have inertia.
It is, and it potentially paves the way for a complete reevaluation of the standard model and a truly unified picture, a universe where structural persistence, mass, emerges from the harmony and pattern of underlying coherence.
Okay, this is where it all really comes together and the implications get, staggering. The standard model. Amazing success, right? Unifying electromagnetism, weak, strong forces via U1, SU2, SU3 symmetries. But like you said, it has gaps. Gravity's not in there. Mass hierarchy isn't explained. Particles and forces seem separate. How do NFNs even begin to tackle these huge challenges?
The NFN framework proposes a really ambitious but potentially elegant unification. It suggests all gauge symmetries, all particles, even dimensions, emerge as coherence reductions from a single, deeper NFN meta-operator algebra, like a single, incredibly complex musical chord that, when you listen closely, contains all the simpler melodies and harmonies within it.
So instead of adding gravity or new particles, NFNs suggest they emerge from something more fundamental. How are the standard model symmetries actually inside an NFN's SA structure?
It's a clever mapping. Each component gets a role. S symmetry operator generates U1 like phase preservation linked to electromagnetism. The universe's constant hum, A asymmetry operator, corresponds to non-abelian SUN generators, crucial for strong and weak forces, the dynamic variations, the rhythm changes. S phase modulator determines phase curvature and defines coupling constants, the force strengths, like volume and tone controls. Recursive coordinate encodes recursive depth, which Lillian links to dimensional unfolding in the SU2 internal freedom levels, the layered complexity.
That's really insightful, suggesting fundamental symmetries aren't fundamental, but hierarchical manifestations of deeper NFN structures. And there's an NFN symmetry reduction cascade.
Yes. The idea is the full unified NFN algebra reduces sequentially, like a complex chord resolving into simpler melodies. Unified U1, electromagnetism from phase symmetry, ASU2, weak force from asymmetry coupling, strong force from recursive depth coupling. The key takeaway, these are not added to the theory. They emerge as symmetry reductions. They're intrinsic.
So the standard model forces are facets of one coherent diamond. Okay, but gravity, the big one, the one that refuses unification.
This is maybe the most radical part. In NFNs, gravity isn't a separate force or just space-time curvature. It emerges as coherence curvature. Lillian gives an equation. RC or incher. Here, recursive scalar defines dimensional layering density. Phase modulator generates connection coefficients for this coherence space curvature. Gravity becomes a tensorial deformation of coherence structure, unifying it with gauge theory because all forces are modulated NFN curvatures.
So space-time warping isn't mass bending space, but differential coherence in the recursive dimension. My weight is about how my coherence pattern interacts with Earth's coherence field. That's a massive conceptual shift.
Exactly. It allows a quantum-consistent gravity where lensing, inertia, time dilation are all manifestations of differential coherence. Where coherence is dense or flows fast, gravity seems stronger, time mics low, space warps. A single explanation.
And the particles themselves emerge from this unified picture. How do the familiar electrons, photons, quarks fit in?
When NFNs reduce to specific stable configurations, they look like known particles. Photons. Pure asymmetry NFNs, simple coherence waves. Electroweak bosons, intermediate A+ configurations. Gluons, deep modulated NFNs reflecting their complexity. And fermions, matter particles. They're described as antisymmetric bifurcations of the NFN field. The huge implication, matter and force particles appear as modes of a single quantized field structure, not separate entities. Everything is pattern coherence.
It really is a grand unified coherence model, GUCM, where SU3, XSU2 of U1 isn't just tacked together, but is a structured coherence reduction of this deeper NFN framework.
Yes, and this GUCM doesn't need extra compactified dimensions or arbitrary unification scales. It's embedded in the inherent structure of the NFN metafiber field. An intrinsic unification, one score for the whole cosmic symphony.
This complete rethinking of forces and particles must also demand a radical new view of the vacuum. We usually think of it empty, maybe with virtual particles popping in and out. How does NFN theory see this empty space?
Not empty at all. The vacuum is an active coherence field, a coherence-dense metafield. It's the ground state, yes, but defined by maximum coherence symmetry, not just minimum energy or absence of particles.
So it's brimming with potential perfect hidden coherence, like a silent concert hall ready for any symphony.
Precisely. In this ground state, the asymmetry A and recursion components are latent, superposed, holding their full potential. The vacuum is the substrate, the cosmic clay, from which particles, forces, space-time layers are projected and shaped.
If it's maximally symmetric, how does anything emerge? How does the symphony start from silence?
That's the job of the asymmetry operator, A. Lillian suggests A introduces structured distortion into the perfect coherence, not random defects, but precise resonance triggers guiding emergence. An asymmetry field acts like a coherence derivative, creating localized breaks in global symmetry, allowing structures, particles, fields, dimensions to emerge. It replaces symmetry breaking with asymmetry resolution, a directed unfolding controlled by coherence gradients, not randomness.
So not a random break, but a structured unfolding, like one note gently starting a melody. What about zero-point energy, that quantum fizz? Is it still random noise?
Big departure here. NFNs propose structured oscillation in the vacuum. Deum NT plus. The vacuum isn't randomly fluctuating. It's undergoing active harmonic modulation of latent structure poised to generate reality via precise coherence phase transitions. It's not noise. It's a finely tuned active harmonic ground state. A subtle cosmic hum or heartbeat, vibrating with potential.
Not random fizz, but an organized vibration, a cosmic hum. And these oscillations can lead to vacuum condensates.
Yes. When coherence eigenfrequencies align in this active vacuum, NFN condensates can form, stable but perhaps not fully observable. Lillian suggests these could explain dark energy as a slow, coherent vacuum drift exerting pressure, or neutrino mass as off-resonant condensation. Crucially, without resorting to stochastic randomness, they form dynamically from the vacuum's own structured oscillations.
So they're intrinsic to the vacuum's coherence, not added extras, and each emergent particle corresponds to a coherence threshold.
That's right. Each observable form needs a specific quantized amplitude or curvature gradient sufficient to resolve into form. These thresholds, said threshold, are resonance gates projecting latent vacuum structure into the observable world. This scales from particles up to cosmogenesis. Maybe the Big Bang itself was a coherence projection governed by NFN phase transition, not just an explosion, a continuous unfolding.
This has such deep implications for quantum mysteries. Entanglement, maybe, isn't spooky action, but shared NFN vacuum mode structure. And measurement isn't collapse, but just crossing a coherence threshold where an eigenmode becomes observable. It seems to dissolve paradoxes.
It aims to. It offers a potentially more elegant deterministic picture. The coherence vacuum becomes an active, dynamic, almost intelligent substrate, replacing randomness with harmonic field logic, a shift from a mechanical universe to one driven by inherent pattern.
This theory really does turn things upside down, from the smallest to the largest scales, leading to some mind-bending cosmological and ontological ideas. Like the universe's beginning. Instead of a Big Bang, a big emergence, what's the difference?
Big emergence means it didn't start from a singular chaotic point. It emerged as a coherence reduction from that omnilectic vacuum, the maximally coherent ground state. It's layered. Coherence gradients unfold dimensions. NFN quantization shakes particles. Asymmetry sculpts topology. Like complex origami unfolding from a coherent pattern, not a firework. The cosmos emerges from structured projection of phase-resonant vacuum layers, breathed into being.
Not built violently, but unfolded from potential, like a symphony building from silence. And gravity as coherence curvature? What are the grand scale implications?
Cosmologically, effects like lensing, inertia, time dilation aren't mass-bending spacetime. They're manifestations of differential coherence encoded in the recursive component. What we call mass is a consequence of reduced coherence curvature, a local warp or density in the coherence field, not the primary cause. It offers a quantum-consistent gravity tied to coherent structure and layering, not a force, but a texture of coherence.
An elegant reimagining. And this also impacts quantum measurement, that core paradox.
Absolutely. A quantum state, like an electron wave, isn't inherently uncertain. It's a partially reduced NFN field, a coherence pattern not fully resolved. Measurement isn't mysterious collapse. It's simply crossing a coherence threshold where an NFN eigenmode becomes observable, like a song becoming distinct at a certain note. An entanglement, shared vacuum mode structure of separated NFN fields. They're part of the same underlying coherent pattern. It offers a potentially coherent, deterministic resolution to quantum puzzles, reducing the observer's arbitrary role.
Removes observer-induced randomness, makes it a structured process. What about dark matter, neutrinos, those ghost-like things?
The NFN model naturally allows states that don't fully project into visibility. Neutrinos might be partial eigenmode condensates, stable coherence not fully manifesting as particles. Dark matter could be off-resonant NFNs or invisible coherence fields below our detection threshold. Coherence that doesn't sing at a frequency we hear, but still influences structure gravitationally via coherence curvature. It reframes the search not just for particles, but for these invisible coherence fields.
So dark matter isn't missing mass, just coherence, not resolved for us. And time itself. Still universal and linear.
No. Time here is emergent, a vector field defined by the gradient of phase coherence over recursive depth. It emerges from the changing relationship between layering and phase alignment. This unifies different concepts of time, thermodynamic, relativistic, quantum. Local time dilation can arise from phase differentials. Time asymmetry, forward flow, might come from cascading coherence loss, continuous unfolding, not just entropy. Your time experience might subtly differ from mine based on local coherence.
Incredible. Time is a function of coherence evolution. Dynamic. And physical laws, constants like C, h bar, g, still fundamental.
In this framework, laws are projected invariants from the NFN algebra. Constants like C, G are threshold resonance scalars, critical values defining coherence transitions or observability. Dimensions aren't fixed, but are activated states of coherence layering. The universe revealed by NFNs is living, resonantly recursive, phase-evolving, and ontologically generative, dynamically creating and organizing itself.
Connecting this to the big picture, it really does sound like a universe not built, but sung into being. A continuous act of coherence modulation, not a static structure. Every particle, force, moment, part of this grand unfolding cosmic symphony. It is a profound unifying vision, everything emerging from deep, coherent interactions. A constantly self-generating, self-organizing system.
And that brings us towards the end of our deep dive into Philip Randolph Lillian's, well, frankly, groundbreaking 2025 paper on Noetherian Finsler numbers. We've looked at how this new kind of entity acts as an operator, changing how we think about numbers, particles, forces, reality itself. How coherence becomes fundamental, replacing energy or force. How the vacuum isn't empty but active, generative. How forces unify as projections of deeper coherence, even reimagining space and time as emergent. This NFN framework really invites you, the listener, to rethink not just physics foundations, but the very grammar of emergence. A universe where space, time, matter, forces emerge from a four-tuple operator algebra, where the standard model appears as layered projections and gravity is coherence curvature, where the vacuum is the generative substrate.
Indeed. It leaves us with a really provocative thought. What if all physical structure, everything you see and touch, is just the ongoing expression of coherence modulation within this vast generative field? This isn't just science, it's about understanding how being itself emerges. It challenges us to see existence as this continuous act of coherence modulation, and to understand ourselves not as passive observers, but active participants in this incredible unfolding cosmic symphony.
It really asks us to think about how deeply our own perception, our own coherent state, might be intertwined with this universal structure. The NFN journey traces form back to formlessness, force back to field resonance. It's a powerful physics of how being itself emerges constantly, dynamically, harmonically.